Hello, guys. Uh, Welcome to the video. I'll be coding live, but I think by the time you watch this, it won't be. Okay. So I'm about to do. Let me see. What is this? This is practical programming test 2 from the 9th of May 2019. All right. So uh, yeah. So this is basically gonna be um simple encryption using strings in C++. Uh, so hopefully you have the brief in front of you. I don't feel like reading out this whole question, but yeah, I'm not gonna read it out. Uh, all I want us to focus on is that we need to swap certain letters out depending on the length and if it's odd or even. Okay, so that's also length. Okay, cool. Let us begin. So I just want to write a heading here. Uh, so this is one test two. This is going to be simple. Simple encryption. Cool. Strings. Cool. Okay, guys. Let me just read this out here. Then 1, 2, okay. So, encryption is the process of converting data to an unrecognizable form. It is commonly used to protect sensitive information so that only authorized parties can view it. You are required to implement an encryption algorithm to hide plain text words. The encryption algorithm for a given string word is as follows. So if word is of any even length, the following encryption applies. We need to swap pairs of letters in word as follows: first and second swap, third and fourth swap, so on and so on. Second, last, and last swap. So, an example, if we are encrypting the word baking, this would give us ABIKGN because B and A swap, making the first two letters AB, K and I swap making the next two letters IK, N and G swap making the last two letters G N. Okay. Example. Another example would be encryption of the word to would give OT because the first and second letter swap. If word has an odd length greater than 3, the following encryption applies. Swap the first and second letters and swap the last and second last letters only. Example of this would be encrypting the word watch would give AWTHC because W and A swap to give AW. Nothing happens to T and C, and H swap to give HC. sorry, nothing happens to T, and then C and H swap to give HC. Yeah, words not meeting the above criteria remained unchanged. For example, you, now, A, and I would remain unchanged. So you are required to read in text from a file named input.txt and convert each word in this text to an encrypted form using the algorithm detailed above. Note, um, each line in the input file may contain any number of words separated by spaces and or punctuation. The input file may contain any number of lines. All punctuation should be ignored when encrypting a word and should not appear in the output. The encrypted input text must be written to a file named output.txt and must have the same structure as the input. That is, each line of the output file must contain the encrypted word separated by spaces from the corresponding line in input.txt in the same order. And then they gave us some useful functions. I'm not going to read those out. Uh, all right, and then we're given the example text, right? So what I've already done is create a text file and put in this example one. So let me just show you. So I'm just going to show you now what is in my input file, and it's very important that you make sure that you're reading in data correctly. So after you make a text file, uh, make sure you're reading it incorrectly. So I'm just going to test that now in front. I'm assuming everyone knows how to read in from a file by now. Okay, so I'm opening my text file that I made called input.txt, and I'm going to read in the first sentence, right? And normally what we would do, for example, would be let's create a temporary variable of type string and say while in file while you pass data from in file, I mean through in file, because it is uh, an object of type stream, so it allows us to access information from the input text file. So while we're reading it from the object into temp, right? We would say, yeah, do something with temp, right? But now if I just see out temp, it's going to give me, or it should give me individual words from the input file. Okay, if you look at the bottom, uh, so it's like, it's not whether you get knocked down, but whether you get up. Okay, so it is um, getting the correct words, right? But it's not. Let me remove this. Just want to show something, right? So it's kind of just taking the words, and it's going to be difficult to separate, uh, to know where each word ends and the next begins like this. So instead of using this method, what I want us to do is use getLine. And if you're not familiar with what getLine does, instead of taking um, a word uh, and then end at the space, it will take the whole first line in your text file and then save it into whatever variable you give. So this is the format of taking something from the text file using getLine, right? So since I want to show you all that I'm just getting the first line in your text file, I'm just going to do this, getLine, and then where it's coming from and where you're putting it into. And now I just want to see out temp. Okay. Yeah. So what I'm supposed to be getting out is the first sentence given there. Okay, so that's what we get, right? It's not whether you get, right? That is the first sentence. If you check the brief, I'll just skip a line so that this notification shows up below. Yeah, it's not whether you get, so that's the first line in our text file. And then this just shows me that the program executed successfully with no errors. Right. Since we are told that there we don't have a fixed number of words we're getting in or sentences, what we can do is say while it is possible for us to get um, get lines from the text file, we're going to perform some operations. So what this code will do is record in temp each line in the text file, and then after that's executed, it will then go down one line and then save that line, and then go down one line and then save the next line. So I'll just run and show you that it actually works. Okay, so this is us reading the entire text file, right? So there's the first line, the second line, the third line. Okay, so let's go on. It's important that you make sure you are reading in your uh, your data or information from your text file correctly. Um, okay, let's go on. Um, okay, next step. So what we're getting in from our text file, the first time this code runs, is that we're getting the first sentence. Okay, so that's a number of words, but the way we brought it in was by string, so it just records all that as one string. So we need to make a way to separate this long string into words so that we can then change the letters in each word. Okay. All right. One thing I want to say is that um, one thing you should know about strings is that a string is an array of characters, right? And that means that you could have, so this is what a string looks like. Okay. Uh, Based on the definition you just gave, is that if each of these blocks represent storage units in our array. Each block can hold a character. That's why we know strings are an array of characters. Okay, let's continue. Right. So I'm going to be using functions to do each step of this code. And the first function we're going to have to use is one that will break each sentence into words, right? So I'm going to call it get word. Okay, get word. And get word would then take in temp, right, which is my string that I'm going to manipulate. So I can in above int main make my function, and for now I'm going to leave it as void. I'm not sure yet if I'm going to return anything, and this is going to take in a string, and I'm going to call it sentence because that's what get word that's where we're going to be getting our word from. So we're going to take in a sentence and then get a word from that. So okay, so what do I want this? How do I get the word out? Remember, uh, oh snap. Okay, before I let's just comment this out. Uh, for now. All right. We read in the brief that all punctuation should be ignored when encrypting a word and should not appear in the output. Right. So as immediately as we get our sentence in, right, let's just remove all punctuations. That only makes sense. The first line doesn't have a punctuation mark, but I'm going to make a function because the other two lines do. So I'm going to say I'll make a function called remove punctuation like that. And this will also take in temp, which holds my current line, and I'll make a function. I'll make it void remove punctuation. Actually, let's make it a string so it returns uh, the sentence that we just put in, right? Uh, let's return the sentence, right? Remember, we're going to do changes to the sentence and then put it back here. So temp will now equal to the previous temp after remove punctuation. This function has operated on it, right? So in this function, what are we going to do? We're going to use one of the uh, useful functions they gave in the brief. So uh, to search through our line or sentence, we need to actually go through each and every character. And I'm going to use a for loop to do that. So I will act as sort of an iterator to go through the entire sentence. Um, so we're going to run the for loop from the left end of it. So that will be I equals to 0, and it will end uh, what's going on here? Okay, so the for loop will run from I equals to 0 up to um, just one less than the length of the sentence, 9 plus plus. What would be important for you guys to do research on? I'm gonna put it up here, is what is the difference between um, string dot length and string dot size. Uh, and this could be a possible exam question, and it's important that you do know the difference. Okay, so as we go through this sentence, you want to check if there is a punctuation. So if is punctuation. So remember, is punct takes in what? It takes in a character, and you can access a character in a string, a certain character in your string, right? Depending, there's two ways of doing it since it's an array of characters and also a data type on its own, like string. So the way I'm going to use it, or the way I'm going to do it, is using I. So an index, right? So I is my index, and I'm going to say um, sentence dot at I. So if, right, uh, at sentence I you find a punctuation. So if is punct is true, remember is punct is a Boolean function. It either returns true or false. If there is a punctuation, what does it return? It returns 1 if there is a punctuation mark, and 0 if it is not. So true is a 1 and 0 is false. So if you do find a punctuation, take sentence, uh, sentence, I'm gonna use another one, sentence dot erase, right? And remember sentence, string dot erase returns the string, right, with the character starting at position index for length 1 is removed. Okay, so index is I, that's the position of where the punctuation is, and I'm just removing one character because I'm moving through this one character at a time. And then after it clears everything, I'm returning sentence. And this sentence that I'm returning now does not have any punctuations in it. And that sentence will be returned to the variable temp. So now if I see our temp, remember this for loop will run for each and every line. I should see no punctuation marks coming out. Right, so remember there was a comma at down if you check your brief, and a full stop after the word up, and both have been removed. So the remove punctuation function works, okay? Uh, it's important to test each part of your code before you put everything together to make sure you know where your error is while debugging. You know, under test conditions, it's quite stressful, and you want to know what part of your code exactly is not working. Okay, so after we remove punctuation marks, we're then gonna use our get word function. So I'm gonna uncomment that for now. So get word takes in our new temp, right? And the new temp does not have punctuation marks at all. So one of the bullet points that I had in the brief, I cleared it. So I removed all punctuation, so they won't show up in the output file, which is really good. So now as I was saying, our words are separated by spaces, um, and that would be sort of a flag that we can use to separate um, our words in the sentence. So what I'm going to do is make a string and call it word, okay? And this uh, variable will hold the words I make from the sentence. So the words I separate from the sentence. And just like how you initialize variables, when you initialize a string, you want to clear the string or make it equal to a space, but I prefer clearing it because a space is a character as well. I'm then gonna make a for loop because I want to pass through every single character in the sentence, right? So that's the only way I'll find the space. So sentence, same way that we did it above, sentence dot length, right? And then I plus plus. Okay. So I don't know if I can show this to you on my notepad. Okay, I can actually. Let's go there. Right. Taking it. Okay. So uh, what is our first line? It's not whether you get. So this is after removing the punctuation marks. So what happens is that this whole string, right, is my variable called sentence. And I want to separate this into separate words. So that's a word, 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 right? And in between, what separates them is spaces, right? And spaces are also characters. So as this for loop goes through each place, once I get to a space, I want to say, okay, take what you have so far and do something with it for now. We know later on we're gonna have to check if it has more than three characters, whether it's odd or even, whatever. But right now, I want us to be able to, at this point, be able to take what is behind the space and then use it. Another thing I wanna uh, make you give thought to is the fact that get is the last word in the string and T is the last character. So um, our algorithm that we're going to use of finding spaces might not work at the end. So what we should do for now is actually put a space in there, right? And that will show us that the word that this uh, word actually that get, right, also gets taken as a word because without the space it won't. So I'm gonna put in a space right now and then use that to get words, okay? So let's go back there. Cool. Okay. So another good thing about strings is that you can use the plus sign to add characters or other strings to it right now. And yes, I can do this, is I'm going to take temp, and as I showed you, I'm going to add a space at the end so that that last word that I have also gets taken, like it also gets separated from the string. Otherwise, it won't pick up that, okay, this, I need to break and make this a word. Okay, so I have a for loop, and I want to separate words. So if you find that there is a space, so is space, right? This is also a special function that's given to you. And where do you find the space? You find it in the string. Did I spell it correctly? Is space, yes. No, sorry. Sentence. Sentence dot at I, right? Because this runs. And then if that is true, remember it turns true if it does find a space, then I need to take it somewhere else. So I'm gonna make another function here and say and call it encrypt. And what am I gonna encrypt? I'm gonna encrypt the word that just came in. Okay, so you might be asking yourself, okay, we made word, but right now, okay, let me just make this function called encrypt. Encrypt. I'll make it void for now. Encrypt, and it's going to take in a variable of type string called word. So, all right, let's get back here. So you might be asking yourself, okay, word right now is totally empty. So I'm going to be encrypting nothing, right? So what I'm going to do is construct the word, right? So word will equals to uh oh, all right. What I didn't clarify is that if there's a space, you come here. So else uh, word will equals to sentence dot add I. All right. So it's like if you don't get a space, keep adding characters uh, to word, but I need to take in consideration the previous length of word and edit. So let me just illustrate what I'm actually doing now. So what I'm doing is like, let's say it's okay. So at this point, I is 0. So I comes in, it's not a space. So what does it do? It goes to word, which is equals to word plus sentence at I, right? So sentence dot at I, which at current I is 0, so at 0, but I'm gonna put it as I, okay? Uh, and then what's happening is that, remember in the beginning, this is empty. So this is empty. And now this is I. So word for the first time becomes just I. Then the loop runs again. I is now 1. So what happens? This becomes T, right? This is no longer empty. This is I. So now it's I plus T. And then um, it gets to S. And then remember now this is I T plus S, and it becomes its, which is our first word. And then we have that function which we did. And what does that function do? It says over here, I'll just mark it, it encrypts the word. So that's what we have. Cool. I hope you understand that part. So it goes I T S. So right now word holds ITS. And then it's like, okay, once you get here, what do? You take word, what it is so far. So far, word holds ITS and take it up to, oops, and take it up to encrypt, which is over here, which we are going to write shortly. Okay. All right. In encrypt, what's going to happen? We're taking in a word, right? And that word has a certain criteria that it has to pass. And depending on the criteria, we'll know how to encrypt the word. So what we're going to do, we're going to write if statement and say if word dot length, right? And what's the test to test if something's even and odd? The mod, right? So you'd say mod 2 is equals to 0. Every even number modded by 2 will return 0 because every even number is divisible by 2. Cool. If the word mod 2 is equals to 0, we need to swap. Okay, so alright, let's just move with this. Just move with this. Okay, before we do encrypt, right? Before we complete encrypt, I want to see if this actually takes a word, right? Remember, I told you that at every stage you need to check if your code's working. Okay, so let's come to main. That's where we're getting our word from. Okay, and I don't want to take in this whole thing because I might get confused uh, as to what word it's or what word it's actually taking, right? So I just want to, for now, take in the first line only, okay? And how I'm going to do that is actually going to comment out this while loop, okay? Because the while loop will run everything. I just want to run the get line code. So I'm just going to copy this, paste it above. So if you can see what's actually happening is that I'm just getting the first line in, in the in file, in our text file. That's going to temp. Then I say temp, remove all punctuations. Cool. So now this temp has no punctuations in it. Then I put it through get word, and get word does what? It takes temp, okay, puts in a space. I explained why we need a space there so that the last word can be recorded correctly. And then it goes to get word, which takes in what? The whole sentence and does what? Finds a space, and when it does, goes to encrypt. So before it gets to encrypt, I'm gonna comment that out. I wanna see out word. So show me so far what you have as word, and I'm gonna end line. And then I'll make sure I have no other outputs, see outs, so that the only word I should be getting there is its. Let's see if that works. Okay, so I'm not okay. See, the first time it gets its right. There we go. And then it takes it because this for loop that we have in get word runs the entire length of the sentence, right? It gets every single word and just adds it to the previous word. So if you can see, there's its, there's not, there's its, sorry, it's not whether, and so on and so on. So this is working, but it keeps adding on and on and on. So in order to prevent something like that from happening, after we get a word which is separated by a space, we want to clear a word so that next time when the next word comes in, it starts it from the beginning. It doesn't have any traces of the previous word that was in there. Okay, so I'm gonna run this. Oh no 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 no! I'm supposed to put it above. Oh, it doesn't really matter. So what I wanted to say is that I wanted to clear the word before see outing, but that wouldn't give us anything when we see out. So can you see now? It takes it prints it out and clears the word, right? So remember in this for loop. So then I is at 0, 1, 2, 3. So when I is at 3, it then starts the next word, which is not. and then after not gets recorded, it then clears that and then takes in the next word and the next word. So the get word code works now, okay? So I'm just going to comment out the cout because I don't need it right now, and I'm putting back the encrypt word. So we were here. So in encrypt word, we take in a string variable called word, right? And what I said is that if the length is divisible by 2, which was one of the criteria we were given, I'm just going to read it out again. If word is of any even length, the following encryption applies. So swap pairs of letters in words. So if you read that part, we're always swapping uh, one character with another, one character with another, one character with another. Okay, so I'm just going to illustrate how that needs to be done. Let's do this. Okay, cool. So we got the word it's. Okay, let's say it runs and then it gets to an even lettered word. So this word has four characters, right? So the length is 4, and that is divisible by 2. All right, so that's mod. That's how I write mod. Sorry if I'm actually writing correctly. So this is mod, not divide. Okay. So all right, down comes in. What needs to happen now? So uh, we need to somehow move through this whole word, and how we normally do that is with the for loop, right? So we're gonna have a for loop, and what's gonna happen? We need to swap. Let's say we're only swapping 1 and 2. Okay, so we're gonna uh, 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 we're gonna start here. Okay, and then so we'll like say, okay, we'll make another string. Let's call it temp again, right? And this temp will hold d for us. So temp will equals to word dot at 0. Okay, so this is at the moment this is d. Okay, and then we'll say word dot at 0. This is a space, right? This is like uh, in memory, this is a storage space that is reserved for a character, right? So at this point of the string, at this I value, what do I say? The first character, which is here, right? What are we saying? We're saying at that point, right? Make it equals to, since we're swapping it, we're going to make it equals to that point there. Okay, that's what we're doing. We're going to say it's going to equals to word dot at 1. Okay, and this currently is O. So far, what happens to our what does our word now look like? It's now going to look like OOWN. Okay, so down becomes OOWN. Let's continue. Then what happens? Now we're going to say we need to change this O into D because we're swapping the first two characters. So we're going to say word dot at 1 will equals to what? Where's our D? Our D is in temp, so equals to temp. And that's it. So what will happen now is that we'll have O, and then we'll have D, and then we have W, and then we'll have N. And what if this? So the reason why we're going to use a for loop is that if the string had 16 characters, right? We can't write this piece of code for each one of them. This one will work for the first two characters, right? But we need to use things like I and run it through a for loop so that we can get every single uh, pairs, like these two pairs of characters and swap them successfully. So we'll have a for loop, and as I said, we're gonna start here at O and not at D because uh, starting at the second one will actually help you know where to stop, if that makes sense. So if I make this one I, right? I know that at I minus one, there's a previous character, right? What if I was at N, right? If I used it the other way around and then I was like, make this I and make this I plus one. Can you see that if I'm at N, I'll go out of bounds? But if I start at N and say I minus one, I know that I keep it in bounds and the furthest I go is I. So that helps me make sure that I do not access memory that's outside my string variable because that could be reserved for something else. Okay, so let's go back to the code. Let's code what we just did. So we said that we're going to run a for loop. The for loop, right, will run the whole length of the word. Okay, and in this for loop, excuse me, you are taking oh yeah, you need to make a variable. So I'm making it outside all the loops, okay, so that I can use it in all my loops because I'm gonna have other uh, encryption techniques besides the ones for even word lengths. I could have one where it's odd and I need to use temp again. So I made it outside. Okay. And I'm initializing temp, and this is how I do it when it's a string variable. I just clear the string and I know that whatever, maybe I used temp before and might have something, so that's clear. Okay. So what I'm doing is saying temp, okay, will equals to what? Word dot at I. And what I said is that we need to start at 1, or we need to start at the second character. Let me show that again because it might be not clear. Maybe not clear. So down, let's take that example again. Like an array, it starts indexing from 0. So if you have a word that has a length of 4, the highest index you will have in that word is 3. Okay, so that's why I said if we're going to start at O to prevent us from accessing memory that's not in our word, we are going to do a start at the second letter, which in index form is 1. That's why my for loop will uh, run from I equals to 1 to I less than the word length. Remember, I will go up to, if it's down, it will go up to what? To 3. Because the last indexing in my word, if it is a 4-letter word, would be 3. Cool. So I make temp equals to what I minus 1. Okay. Why I minus 1? Because the D, right? I want to save temp in D, and then I'm going to replace the D with an O now. So I'm going to say word dot at, what's the position for D? D is at I minus 1, remember? And I'm going to say, at that position, what do I want to store? I want to store word dot at I. Why I? Because I is O, it's at 1. It is the second character, okay? And then I need to replace the word dot at in the second position, right? Which is at I. I'm going to replace it with what? Temp. And that is how, what are you saying to me? Oh, okay. So we're going to make temp. Is that the problem? Okay. Since we are immediately using temp, I'm not going to initialize it, right? Because that's giving me issues right now. And another thing I want to say is that since temp will hold one character in this word string, you can make it of type char, and it will work the same because remember what I said that a string is an array of characters, so that should work. And yeah. What else do I need to do? All right, so I'm going to test this bit of code, but to be able to test that bit of code, remember, now when I get line, the first word that's going to come in is it's, okay? So I'm not going to let it get in there. What I'm going to say is that temp will equals to the word down, okay? Because I want to test if the code I just wrote works. Okay, so temp will now hold the word down. This remove punctuation will do nothing because there's no punctuations in it. Uh, get word will do a take temp, give it a space so that this for loop for get word knows that when I get a space, there it is space, then I know that I can encrypt that word that I just got. Okay, so down gets into word, get word takes it to encrypt, and then encrypt will then do this, okay? And then at the end of all this, I want to see out uh, the word, okay? But I want to do it outside the for loop because it's going to go through a number of characters, and I don't want it to print every single time it passes a character. I want it to print after the for loop, after the entire word has been changed, right? So I'm going to see out word and then end the line. What am I expecting to see? I'm expecting to see the first two letters changed and the last two letters changed. No. No. Can you see what it's done? It's like swapped every single character. I don't want that to happen, right? Why do you think it's doing that? It's doing that because um, every time we go I plus plus, what does it do? It moves. Let me do it here. Every time we go I plus plus, it just moves one at a time, right? But what do I want to do? I want to address them as pairs, right? Like that. And then I want to skip this pair and I move on to that pair. So I want to be dealing with uh, two characters at a time. So what I'm going to do is that after this for loop runs, I'm going to say I plus plus again, okay? And this would skip, um, let's say I'm working with down, so do, it will skip the first, it will do operations for the first two letters and then skip that letter. And remember, there's an I plus plus here as well, so it will be clear of D and O and then go on to W and N. Let's see if that works. I'm gonna run my code. Okay, cool. Can you see it swapped D and O, and then it's sort W and N. So encrypt works for what? It works for even length words. Okay, so I'm gonna remove this N line for now, put it back later. Let's go to main. So I'm going to remove temp as just one um, thingy, one word, and I'm going to allow it to run a sentence at a time again. So now that we're done with that and that works, let's try it for um, the other condition. What was the other condition? So remember, the word comes into encrypt. It then meets this if statement. If it's even, do this, blah blah blah, and then else if what? Else if, let's read the brief again. The brief says if word has an odd length greater than 3, the following encryption applies. Okay, so odd length. Let's do for odd length. What is odd length gonna be? So word dot length, right? Mod 2 is not equals to 0. That means the word is odd, right? But not only that, so we'll use and always remember to use two ampersands and not one, because one will perform the binary operation for these two scenarios. So let's say this one goes through, that will become a 1, and the next one doesn't, that will become a 0, and a 1 and a 0 is 0. So let's say uh, it's this is 0, like, you know what I'm saying? You know what I'm saying? You know what I'm saying? You need to put two ampersand signs. If it was all like one condition would pass and one would fail, but 1 or 0 is 1, so like one of your checking statements won't work correctly. Luckily, this one's and, but still, you would lose marks if you use 1, because that will perform the binary operation. Is it called binary or byte operation? I don't know. Anyway, let's go on. So the word dot length has to be greater than 3, right? And what do we do when this occurs? So this uh we need to swap the first and second letters and swap the last and second last letters only. Cool. So in this one, remember, we only have two cases where we're swapping letters, beginning and end. So we don't need a for loop to run through the whole thing. We know that no matter what size of word is coming in, we're swapping the first two letters and the last two. So we don't need a for loop here. We just need to make specific cases for each one of those, beginning and end. Okay. So once again, can you see where my temp is? It's outside this if statement, so I can use it here again. It won't give me errors. Okay. Excuse me. Corona. I'm joking. Um, um, so let's go again. Temp equals to word dot at what? The position number is 1 for the second letter in the word. Right. So we need to make it equal to the first one. Sorry. So the first one, and then we replace the first. In the first position, we put in the letter in the second position, and then we take the second position and insert the first word. Done. Okay, and now we're going to do the last space. And remember what I said, strings are arrays of characters. So there's an array of characters. So you could use some array functions in here. Okay, so what I'm going to use is, how do you access the last index in your string? I'm gonna do that using um, an array technique. So I'm going to say temp will equal the word uh, dot at, right, at which position? Word dot length stores what? Word dot length stores the last index of the word, but I want it minus one. Okay, that also works. Uh, oh yeah. All right. So does this work? I will test it shortly. No, 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 no. Minus two, and then word dot at word dot length minus two will equals to word dot at word dot length. I think there's a simpler way of doing this. I'm just not familiar with it. Word at one. I hope you understand what I'm doing here. And then word dot at word dot length minus one will equals to temp. Okay, let's test if that piece of code actually works. So we need to put in, okay, let's take a get line again because we're putting in a specific word. So we want to have a tab that has a string that is odd. So I'm going to put in my name. Okay, my name is Kevin. Kevin! And that has 5 characters. So it's cool. So we'll also test if, so V should be unchanged, right? It should be left in there, and IN should be changed around, and KE should be changed around as well. So let's run this code. Errors, errors. Oh, I'm not outing. After you run this code, I want you to output word. So out word, word, end line. Alright, can you see that the K and the E swapped around? V remained in the same position. I and N swapped around as well, which is great. So both our if and else if statements work correctly. Okay, so let's go back to let's change this back so we don't get confused, right? So we still getting an entire line in there. Okay, so far what do we have? We have uh, a string, all right, we called it temp. So we're getting in the first line from our text file into temp, and then what's happening? So we take that string and pass it to remove punctuation. What does remove punctuation do? Remove punctuation goes through the whole string and removes every punctuation that is present in the string and then returns the string. So that string gets passed back into temp. So temp is equals to this answer. Okay. Remember now this string is the same as this one, just without punctuations. Then we take this new string temp, we add a space at the end. I explained why. I'll do it again. It's because we want the last word to be read incorrectly. Okay, because our code get word né, separates words by the use of this function is space. Is space returns true when there is a space character at this point, so at index I. Okay, so temp comes in, it's a sentence, it gets so word just keeps adding characters I, T, S, D, O, W, N. Those are all characters. So like word will now first time will hold its, so ITS. Okay, so ITS gets here, and then there's a space, right? So when I gets to that specific index, there's a space. Then this word that has been building up gets sent to this function called encrypt. So what does encrypt do? Encrypt takes in a word, checks if the length is 2, mod 2 does this, else if it's not even and greater than 3, it does this, right? And then that's where we are right now. So actually, this happens, and then the word clears, and then the next word comes in. So there's no place where we are storing our newly changed word, encrypted word. So what I'm going to say is that I'm going to return word, right? Because it gets changed, and then change. Don't keep it as void. Keep it as make it a string because you're going to be returning a string. So what's going to happen now? Let's make a new variable of type string and call it encrypted string. So the E will stand for encrypted, and then I'll call it sentence because I'm going to construct a new sentence, right, with all my encrypted words in it. So I am initializing sentence, and when you have a string variable, this is how you're going to initialize. Just clear the string. Okay, so we encrypt the word, okay, but then at this point, after encrypting, when you return the word, I want it to be added to e sentence, okay, so plus e sentence. Cool. So e sentence will equals to the previous e sentence. In the beginning, it's 0. I mean, it's empty, it's clear, plus the new encrypted word. So we are building up what? We are building up words, right, in the sentence. Okay. We have a bit of code that we have written so far, and we want to see if actually this e sentence will have all our new words. So I'm gonna see out e sentence and see. But I'm not gonna do it here because yeah, every time a new character comes in, it's gonna print out. I don't want that. I want to do it after this entire for loop. So outside the for loop. See out e sentence and end the line. So it's only gonna run once because I'm taking in an entire first line only. Let's see what comes out. Ooh, okay. So let me compare that to our example given. Let's look at the first line, the output.txt file. What is it supposed to give us? It's not HWETETHRE you get. So we are getting the letters in the right order, but can you see that there's spaces actually missing in between? And why are there spaces missing in between? Because where is it? Where is it? Where is it? Where is it? Our get word function only adds to the word letters that are not spaces, because when it's a space, remember it jumps out of this and does what? It goes to another function. Okay, so what we want to do is somehow add a space back after encrypting the word. Okay, so let's go to our encrypt function. Here it is. So we want to return word, but we want it to have a space as well, right there. And yes, I can do that because I'm working with strings. They're so awesome. I'm gonna run this code again and see if we actually have spaces in between. Yes, we do. Hooray. Cool. I'm moving my cursor over here. Can you see that there's a space at the end because get is also a word, right? So somehow we're gonna have to um, erase that last space. So let's just do that quickly as well. So after this point, I want to take temp. Oh wait, get word, get word, get word, get word comes there. All right. Since I want to return e-sentence, okay, I'm just printing it out from a function. I want to return it back to main so I can use it there. So I'm going to change this void into a string, okay, and then I'm going to return e-sentence, semicolon. Okay, so let's see if e-sentence actually gets transferred here. Whenever you're returning from a function, you want to have something on the left-hand side that you are um, giving the assignment to. So you are returning something from this function. That return will go into what's on the left-hand side, which is temp. So, oh no, no, don't run, don't run. Yeah, there's no output there because I didn't see out. So at this point, let's see out temp and end line. Cool, so that works. I'm still getting the space here at the end. So I didn't write that piece of code. So like we used before, we're going to use string.erase. In this case, it's temp.erase. And we are erasing what? The last character, which is a space, which is not there originally in the text file. Okay, so we need to erase it. Remember, we added a space over here, right? Remember, you don't care about this one that you added in the beginning because in this function, where is it? In this function here, all the spaces are removed because they're not included in the new word that we bring in. So since we're adding a space after our encrypt function, we need to remove it at the end. So erase at temp dot length there -1, because remember, if you have a length of 5 letters, the last index is 4. So you want to go length -1, and that should take you to your last character. So after we delete that, see, there's no more space anymore at the end. Cool. So it works, but it works for what? Only the first line. So you need to check if it's gonna work for each and every line that comes into temp. Okay, so let's leave that C out there. I'm going to uncomment this while loop here. Remember, I'm gonna remove this get line because that just gets the first line. This while loop gets what? Every single line in the text file. I'm running that. Let's see what we get. Okay, this is what we get. Let me compare it. Yeah, okay, cool. That is correct. So yeah, we're done. Okay, we're not actually done. I don't know if I haven't done this in my previous videos, and I want to do it here. Uh, Remember, just correct your that A style, whatever style you need to format your code into. Okay, cool. So what I want us to learn how to do, it will just take a few extra minutes. is learn how to oh, before we do comments, I wanted us to learn to comment. Before we do comments, okay, we need to take this to an out file. So of stream out file, we need to take it to our output.txt. Okay, so file dot open. Right, so you don't need to make an output file on your desktop. C++ will do it automatically for you if it does not exist already. Okay, that's only for output. For input, you have to make it because it's just like reading in from there, you're not writing to it. Okay, another thing, a lot of get this question where people ask me, okay, do I have to make the OF stream below the IF stream? Do I have to open the out file after the in file? The answer is no. So you only need to open the file just before you use it, okay, and close it after you're done. So this out file right here, okay, I could have put it like down here, okay. I can't put it down here because remember, temp will only store the current line. Because there's multiple lines, I need to somehow record the previous temp before a new string gets stored into temp. Okay, so I'm leaving it there. It's nice and neat. It helps me remember where stuff is. And then all I need to do is, instead of putting C out, I just put what? Out file, which is my object, right? That allows me to record things in my output.txt file. And good coding practice, always close your text files, the input one and the output one. You close them by closing these objects. I don't know, I call them objects. The in file and out file objects. Those are the same ones you named there. Okay, so that is the completed code. You do this and you get majority of your marks. You only lose marks because you didn't comment. Okay, some of you will think you nailed it, but then you didn't write comments. All right, so what I always repeat in my mind before writing a comment is that I need to tell the reader why I did or why I did something and not how, right? So it's like they want to know the purpose of uh, a specific piece of code and not how you did it, because the why is more important than the how. Okay, so let's start in main. It's good to start in main. So for your in file and out files, you could be like um, to read in. Okay, no, don't comment that. Actually, this is what to access text files, and you can put in input.txt. Cool. Oh, and you could put and output.txt. Cool. Yeah, you could put it above, like there. Okay. Yeah, you're opening them. You don't need to comment that because that's how you did it. I'm gonna remove this. Hopefully you'll remember. And then here, it'll be like, what is the purpose of this while loop? The purpose of this while loop is to get each line in text file and encrypt. That's what the whole thing does. right? So why are we running it? We're running it because we want to get each line in text file and encrypt each word. Done. Okay, so this one, to remove punctuations, punctuations. Might want to space your code out nicely. This one is to break sentence into separate words. This one is to what? To fix. Yeah, just say error correction. Error correction. Sound fancy. Yeah, that's why you did that piece of code. Cool. Then you are outputting. So this is writing to output.txt. Cool. Then closing. Text files. I can put this one above because it applies to the bottom line as well. There. Let's go to the functions. Most importantly is to know how to comment your functions. Just say erasing spaces. Oh, this one's for punctuation. Removing punctuations. Sorry. Actually, the whole thing does that. So yeah, it could be like removes punctuations. Yeah, that's all. And it could be like returns sentence. But that's like how, right? So let's remove that. Just leave it as removes punctuations. Returning shows if the person's like confused as to what it actually returns, you could be like, okay, return sentence without punctuations. Please hope my spelling's been fine so far. Okay, the next thing is this encrypt function, right? So we like takes word and encrypts it based on word length. Then returns encrypted word. Done. I think we need to put these comments above the function, just one line above, because it applies to the entire function, not just that one line there. Inside here it would be a how, right? But you could be like here be like for even length words, for odd length words greater than 3. Use math to your advantage, please. Then what's the purpose of this? uh, makes sure um, words are separated by spaces in encrypted sentence. What does get word do? Separates words in sentence. Returns. Oh wait, branches into encrypt function. Then constructs encrypted word. Encrypted sentence. And in brackets you can put the variable name so they know where the thing is stored. Done. What else? That's it, bruh. Like, not bruh, sorry. That's basically like main needs to have like the most because it kind of summarizes what you've done. Like your main isn't that big. Like that's just main. Most of your code's in your function, and your functions need to be more descriptive. I wasn't as descriptive as I could have been, but this is, I think, a good amount of comments for this size of code. And remember to answer this question. So the question again is, what is the difference between string.length and string.size? It's a possible exam question. I know you need to know it for the exams. Um, and You can comment it at the bottom of this YouTube video. Tell me your answers. Another question could be, um, I'm just going to say this one, okay? So, since we are adding um, characters or other strings to strings, and uh, arrays have contiguous memory, meaning uh, it 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 stores each uh, element in the array um, in memory addresses that are next to one another, right? So why doesn't C++, I mean your IDE, give an error that um, the next spaces are actually taken for the string? You know what I'm saying? How does it store arrays? How does the string store arrays if you can easily add and erase characters from it? So please like the video, subscribe to my channel. I'm gonna post more videos before test 2 comes along, and comment below your answers, and I'll see you in the next one. Thank you. Bye.